Okay, so there's two ways primarily that we apply Ohm's law to circuits. And I'm going to show you two of those ways. Now there's a third way, which is the whole circuit idea, and we'll come across that when we look at resistance in more detail later on, especially when we look at multiple resistors in circuits and whatnot. But for today, we're going to look at two ways of thinking about Ohm's law and building in some Kirchoff's first and second laws as well to help us understand and do some problems. So in the first instance, when we look at a circuit problem, we need to look at it individually. We need to look at individual components. Because individual components all have a voltage, a current, and a resistance. Okay, every single component has those three things, and that's why Ohm's law is so useful. Is because every component would have a voltage across it, or PD, a current going through it, and a resistance as a result of that current passing through it. So what we've got here is a situation where we can look at individual components. We can also look at whole branches. Because once or loops, depending on whose law or what law we look at. So depending on how we utilise Ohm's law depends on what perspective and what values we've been given. So let's look at our first example of individual components. So nice and simple to start out with. If, for example, I have a, let's say, a 200 ohm resistor with 4 volts across it. So I've got my voltmeter across there, and I measure out 4 volts. Well, I know two things about this resistor. That's one of the first things you want to look at. I know two things about it. I know its voltage, and I know its current, and I know its resistance. So I can write them down. Voltage equals 4 volts, resistance equals 200 ohms. So what can I find out about this? Well, I can work out the current. If V is equal to I times R, therefore I is going to be equal to V over R. And so as a result, we can put some numbers into that this time, and we can go, okay, well, voltage is 4 divided by 200. That gives us 0.002. Number 0.2, sorry. And that effectively tells us the current that is running through that resistor. Based on the voltage or PD we've measured across it, and based on its intrinsic resistance, we are going to get a current of 0.02 amps running through that. Well, we can take this a step further, and like I said, we can look at it from a whole branch perspective. So now I'm going to introduce to this circuit yet another resistor that has a voltage across it of 3 volts. But I don't know what the resistance is. So I don't know what that resistance is. Can I find it out? Well, some of you might be going, well, surely not. I only know one thing about this resistor. Well, actually, you know two. Because what you should realise is that any two components in series would always have the same current. They have to. So this has the same current as this, so that means that has 0.02 amps running through it. If that's the case, that means that we can apply Ohm's law again. So if V is equal to I times R, that means that R is equal to V over I, which in this case is 3 volts over 0.02 amps, which should give you a nice value of 150 ohms when you work that out. So do you see what I mean by whole branch and individual components? So we're applying Ohm's law based on what we understand from circuits and essentially Kirchoff's first law, which is the conservation of charge here. So what if I change this up very slightly then? What if I change it and I make it so that we add a power supply and we change some of the values up a little bit? So we're going to add power supply. And we're going to say that power supply is 12 volts. We're going to say we're going to get out across this resistor 5 volts. That's what we've measured. So we can calculate what we're going to get out across this one. So we can go, oh, lovely, we can work out the current. So I've got 5, so as before, V over R will equal I. So in this case, 5 over 200 will give you the current, which is 0.1. We'll have to work that out. So 5 divided by 200 is 0.025 amps. So happy days, we've got a current of 0.025 amps running through there. And as we would suggest before, we could go, oh, that means that in any series circuit, that means that we've got a current running through here of 0.025 amps. And that's correct. That is the current running through that resistor. But we've got a problem now. We've got a problem along the lines of, well, I only know one thing about this resistor. I only know the current running through it. And I want to work out the resistance. Well, can you see any other laws that we can apply here? Hopefully you can. Hopefully we should be seeing is that we've got a 12 volt EMF up the top here. We've got 5 volts being used, so what must be the voltage across this resistor? Well, what you put in is what you get out in any loop. This is Kirchoff's second law. So this voltage across here must be 7 volts. So we've applied and we've used Kirchoff's second law to help us work something out that we didn't already know. And now we've got 2 pieces of information about this resistor. We know the current and we know the voltage. So if we know the current and the voltage, if V is equal to I times R, then R is equal to V over I. So that means we can do 7 volts divided by 0.025 is 280 ohms. So we've worked out that that is 280 ohms. And that is just the start of the laws that you can apply. How do we go about thinking about applying these laws? So there's a nice little methodology that I've come up with that you can use to solve these problems. Step number 1. Identify any components with 2 pieces of information. Okay, so have they got a resistance, have they got a current, have they got a voltage? In order to utilize Ohm's law, they need to have 2. If any do, then you apply Ohm's law as required and you get any missing values. Number 3, what if you haven't solved everything? What if you've come unstuck? What if you've only got one piece of information about a component? Well, then you need to essentially almost go back a step and say, okay, well, what laws can I use? Because the moment you start saying, oh, I can't use Ohm's law anymore, I've identified that I've got no more components that have 2 pieces of information about them, then I need to use the Kirchoff's first law, Kirchoff's second law. What laws can I use? What can you use then to find out? So find out missing values. either by Kirchoff's first law, the current law, or Kirchoff's second law, the one about voltage in loops. So once you've done that, you can then, I go back to step number 1. You identify components with two lots of info. You can apply Ohm's law. If you've still not answered the question, we then go back and we say, what laws can I use? If we still haven't answered all the question, we go back again. And that is the process by which you should be approaching these circuit problems. Step by step, what have you got 2 pieces of information for? Use Ohm's law. If you can't use Ohm's law, you need to then fall back and try and use some of Kirchhoff's laws to solve any missing values. And that is the process which I'll be testing you on when you get to come into class, and you can have a go at it, and I'm going to give you lots and lots of examples of this. So in the lesson, we'll do plenty of examples. We'll be doing an experiment, and we'll build up your practice and seeing these over and over again, and you'll get better at them as time goes on.